Okay, now we're finding the, we're doing question 3 on the review for 8.4. And it says find the, these double bars mean magnitude of V. Given that V equals 8i minus 6j, the magnitude is just, we just use the Pythagorean theorem. So the coefficient on I is 8, and we're going to square that. And the coefficient on j is minus 6, so we'll square that. And what we get is the square root of 64 plus 36, which equals the square root of 100, which equals 10. So the magnitude, and let me do it down here, of this vector is 10. And by the way, that's found on page 322. Now we have to find the unit vector corresponding to this vector. So we'll call it this is 4. So U equals V divided by the magnitude of V. And so that's going to equal 8i over 10 minus 6j over 10. So now U equals, reducing that, we get 4i over 5 minus 3j over 5. And that's our claim. That's what we claim as the unit vector. But let's make sure that's true. So what we'll do, we'll find the magnitude of U. And it better be 1, otherwise this is not the unit vector. So Pythagorean theorem again, and we'll take 4/5 and we'll square it, and plus and minus 3/5, and we'll square it. And what we get in the denominator is 25, common denominator. And if we square 4, we get 16. And if we square -3, we get 9. And so what we get is the square root of 25 over 25, which is 1. And the square root of 1 is 1. So this is indeed the unit vector. So now we're going to, we're dealing with question 5 on the review for 8.4. And we have to find the direction angle between I and V, or excuse me, between I and V for V equals 3i plus 3j. And the direction angle is an angle such that 0 is less than or equal to alpha, the angle which is less than 360 degrees. So then to find the angle, we know that V equals 3i plus 3j. So then the tangent of alpha equals the coefficient on j over the coefficient on I, which equals 1. And the alpha then equals the inverse tan, we take the inverse tan of both sides of 1, which is 45 degrees. So alpha equals 45 degrees, and we found the direction angle.